In this video, we will look at how to fetch and structure historical market data programmatically using Python and the Kite API. As an aspiring data scientist, one of the most valuable skills you can build is the ability to source real-world data, especially time series data like stock prices. The motivation behind this code is simple: to fetch historical open, high, low, close data and then convert it into clean pandas data frame. This is typically first step before doing something like technical calculation or a backtesting of the strategy or even training ML models on the market data. Now let's quickly look at the libraries. We will be importing request library to make HTTP request. Since the Kite API is a REST API, we'll need to allow the endpoints to be called programmatically, and also we need to authenticate ourselves by providing the API keys. We'll also use pandas for reading the CSV file, and then JSON is used to safely load our API credentials and access token from JSON files instead of hard coding them, because that's the best practice. Before jumping into the code, let's understand the overall workflow. We'll be loading the instrument master data file, which help us map trading symbols like Reliance Infosys to the internal instrument tokens, which Zerodha has set. Then we'll be loading the API credentials securely, prepare the request parameters such as time, then call the historical data endpoint using the instrument tokens and the Kite headers, then pass the response and build a data frame that is ready for further analysis. Summarizing the key steps, it will be loading the data or loading the instrument data, then authenticating ourselves and then fetching the data and then structuring it for technical analysis and machine learning modeling. Now going into the code, the first step is to import all the necessary libraries. Then we'll load the instrument data using this pd.read_csv method. We'll be calling this HTTP. Then if you look into the explore this data instrument, will be actually containing 1,34,841 rows. So it includes all the active scripts in the market with 12 columns: instrument token, exchange token, trading symbol, name, last price, expiry, strike, tick size, lot size, instrument type, segment, and exchange. In this, we have filtered for the instrument token 738561, which is the instrument token for Reliance. We can also filter the data set using trading symbol and segment to, if we know the trading symbol, like here we have filtered for Infosys, which is Infi. Now this step I have done because I want to understand how the mapping is done in this data set. So if I want to know what is the instrument token for Reliance, then it's 738561, and similarly for Infosys it is 408065. So this is a very crucial important step to identify the instrument token, because this will be feeded as the one of the parameters in our endpoint URL. Then we are loading our credentials data here in a very safe format. So I've kept all the API keys that I have for Zerodha in login credential.json file, that where the API keys and API secret keys is, and then the access token for each day I'm storing in the folder access token. I'm loading the access token from this part. It's a best practice to store credential outside the code base, for that it will be safer and will also be production friendly. Now next step will be to get the data, for which we need to pass our parameters, tokens, and headers. Headers is where the API gets the authentication and it verifies who you are and whether your token is valid. If authentication fails, then you will not get a proper response and it will be a 404, 403. Here we are getting response as 200. That means it is a valid call. That means it's a valid API call. Going into this endpoint URL, you can see the two important parameters here. One is token, which we are feeding from this list. So the first token is getting into this endpoint URL, which is Reliance script, and then you can also parameterize this 15 minutes interval as another parameter. This is normally to indicate what interval data points we require for that particular token. If you look at the data which we have got in the response, and we load it using the JSON method, you can see this is a dictionary format, which is a list of lists, and it's having the first data point as a timestamp, and then it gives you several values, which is open, high, low, close values, and then the final one is the volume. We are not getting an open interest because it's a equity stock, so open interest is not part of this data. To pass this JSON in a data frame, we can use the columns, data, and candles to fetch from the dictionary and then pass it into pd.data frame with columns specified as timestamp, open, high, low, close, volume, and open interest. Now, if you just look at the data types of this data frame, we have timestamp as an object. That means it's a string, and rest of them are numerical values. Now we have a clean structured data frame, which is perfect for visualizations, technical indicators, and machine learning pipelines. At this point, we are ready to further improve our data types. Like timestamp, we can convert it into data time format, and also we can create the function out of this whole steps that we have done. So in this function, we can then loop over different tokens and provide the time duration that we need the data from, which further you can store it either in a database. So this method is basically used to fetch multiple instruments, then store it in databases, and further iteration in machine learning models. So if you're aspiring to work in quantitative data field, then I think mastering these workflows is a big win.